Hi everyone, hope you're doing well. This is a video to go over do now number 15 for our Regents review. Please make sure you post all these pages for me on Google Classroom so you get credit for the classwork. And yeah, today's is just a bunch of different things, so there's no specific topic. So here we go. Number one, what equation represents the axis of symmetry of the graph of the parabola below? So remember, axis of symmetry means the vertical line through the vertex. Okay, remember vertex is this middle dot right here. So you're looking for the vertical line that goes right through it, and it's 1, 2, 3 to the left. So x equals -3. Again, that's your axis of symmetry. X equals -3. So that one wasn't too bad. All right, number two, vertex and axis of symmetry. So kind of the same thing as this, but just there's no graph to look at. We have to do it algebraically. So for this, we need to know the a, b, and c. So a is 1. That's the coefficient of x squared. B is -16. I'll write that here, ax squared plus bx plus c. So you can see where I'm getting this. And c is 63. So to start off for the axis of symmetry, you had to know this formula, -b over 2a. Okay, so that's going to be the negative of -16 over 2 times 1, which is +16 over 2, which is 8. So that's our equation for our axis of symmetry. And then to get the vertex, remember, you already have the x value. This is already x. So what we do is we go back and we plug in to the original equation. So anywhere I see an x, I'm going to put an 8, and then I follow order of operations. So x1 is a 64 minus 16 times 8 plus 63, which is 64 minus 128 plus 63. Put it all together, and you get -1. So we have our x, we have our y, and our coordinate is 8, -1. Now, if it doesn't say algebraically, now notice this didn't say algebraically at all. You could just put these into the y equals. So x squared minus 16x plus 63, and you could just go to the table. All right, and then basically you want to look for the symmetry. And there we go, right? 8, 8, 3, 3. And there you go. That is your middle point. That's your vertex. And whatever the x value is, that would be your axis of symmetry equation. So if it doesn't say algebraically, can do the table as work, or can show, let's write that, can show the table as work. Okay, so I'll just quick copy this down and then we'll move on. So 5, 8, 6, 3, 7, 0, 8, -1, 9, 0, 10, 3, and 11, 8. And that right there, again, is your, not only your vertex or your turning point, but the x equal 8 is the axis of symmetry. All right, number 3. So this is a literal equations. Actually, 3 and 4 both are. This one we're going to solve for y, and this one we're going to solve for b. So most of you, I think, would multiply by 4, so I'm going to do it that way. And again, we're solving for y, so I'm going to subtract 4z on both sides. I cannot take 4z away from 9, so I'm going to write 9 minus 4z. Then I want to divide both sides by 4, and I get y equals 9 minus 4z over 4. But remember, there was another way to write this. You can write each term in the numerator over the individual denominator, okay? And then what that reduces to is 9 over 4 minus z. Okay, see how that, though, actually, that's an answer. Those 4's cancel out, so leaving you with just a z. Okay, there is actually another way to do this. I don't know if some of you would have started out this way, dividing by 4, and you get y plus z equals 9 over 4, and then subtract z on both sides, and you get 9 over 4 minus z, which is essentially what I got here, so it's really up to you. All right, this one, number 4, you know that the Regents is big on formulas. They love formulas, so we need to get rid of, so it's good that we're practicing this, and you've done this before. We need to get rid of the fraction first. So get rid of fraction first. That's really important. So we're going to multiply by the reciprocal, or multiply both sides by 3 over 1. So this is going to give us, it's 3 over 1. So 3v, those cross out, equal bh. Again, I'm solving for b. So in one step, just divide by h, and you get 3v over h. And that's number 4. Okay, next page. Number 5, factoring. So the reason why I chose this one is because you have to be careful, x to the 4th. We usually don't do a lot of x to the 4ths, but I want to practice it because it came on the Regents. So this technically still is ma'ams, okay? You're going to bring down your first sign, multiply those to get your second sign. What multiplies x to the 4th? So again, you're usually used to seeing it x squared, so we do x and x. This time is x to the 4th, so it's going to be x squared and x squared, okay? So you're still doing what multiplies to 24 and adds to negative 10. So that would be, that would be 6 and 4, okay, right? So x squared times x squared is x to the 4th. This gives me negative 4x squared and negative 6x squared, which gives me negative 10x squared. And those constants multiply to 24, so that's good. The only thing, and this makes it even trickier, is that this question, when they gave it on the Regents, notice this right here. You could keep going, actually. You could do DOPS for that. Remember, difference of perfect squares. So subtraction, binomial, perfect squares. So we can do one more, which is DOPS. So notice it did not say factor completely. And on the Regents, it won't. It just says factor. So you have to know to keep going. Okay, so for DOPS, you're making conjugates. 1 plus 1 minus, square root of x squared is x, square root of 4 is 2. So that is actually the final answer. That was a really tricky one. Okay, number 6 is just some exponent work. Notice that you do see this term squared. So I'm actually going to write it out. I think it might be a little easier. So squared just means I would write it twice. So once, two, twice. I'm going to bring down that. And I'm going to bring down this. Okay, so now you want to multiply. Remember, when you multiply, that's when you multiply the coefficients and add the exponent. So let's do that. 3 times 3 times 2. So it's 9 times 18. 3 plus 3 is 6. 1 plus 1 is 2, plus 3 is 5. Okay, so bring this over. So now we're going to divide. So divide, you want to divide the coefficients, and you want to subtract the exponents. Okay, so I'll kind of bring that answer over here. 18 divided by 6 is 3. X to the 6 over x to the 1st. Again, we're subtracting. 5 minus 6 is negative 1. Okay, remember, you can't leave a negative. Can't leave negative exponents. So we have to convert it. Okay, we're going to make all these fractions. So we're going to make 3 over 1. X to the 5th is going to be over 1. Those are our positives. And now our negative, we do the reciprocal. So you put the 1 on the top, the y on the bottom, and the negative becomes a positive. And then you multiply across. So 3 times x to the 5th times 1 is 3x to the 5th. 1 times 1 times y is y, and that is your final answer. Okay, number 7, Lori rents a car for $87 a week plus 28 cents a mile. How far can she drive to the nearest mile if she wishes to spend a maximum of $200 for 1 week? I know you're going to be so excited to do this question right now. I'm sure some of you are definitely complaining at the moment. All right, not too bad. Okay, we'll go through quick. So x equals the number of miles driven. All right, let's see. We have $87 a week plus 28 cents a mile, and mile we said was x maximum. So remember, that usually means something big, like you can spend a maximum of $20 on something, which means you can spend $20 or less. So this is actually less than or equal to 200. So we're going to solve. So subtract 87 on both sides. So 0.28x is less than or equal to 113. Divide both sides by 0.28. And you get in the calculator, I need to move this over a little bit, x is less than or equal to something. 113 divided by 0.28. Ooh, that big long. Okay, so you have to write every single number and dot, dot, dot. Okay, you know how the Regents always gives you ones that never work out. 286, dot, dot, dot. So 571, 428. Yes, okay. So I'm going to write always, write all of the numbers. And don't forget that dot, dot, dot. That's really important. Okay, so we need a nearest mile. So a whole number that's less than or equal to 403. And we want the biggest number possible. So what's the biggest number you could put here? Biggest whole number you could put here that's less than 403? Well, that would be 403.571, blah, blah, blah. That would be 403. So she can drive a maximum of 403 miles. Now, why is it not 404? Is 404 less than 403? No. And now you have 402, 401. All those would be less than. We want the biggest of all those. So that's why it's 403 miles if she wishes to spend a max of $200. Okay, check. So 0.28 times 403, that's 112.84. Add 112.84 to the $87 fee, and that's 199.84. And 199.84 is definitely less than or equal to that 200. That's no good. So remember, you have to do one that's wrong also. So we'll just do the 404, and that's 113.12. 113.12 plus the 87 fee is 200.12, and 200.12, is that less than or equal to 200? No, it is not. And there you go. I know you miss doing those so much. All right, number 8, this is kind of a tough one. So I wanted to practice it. What is the equation for the value shown on the table? So usually you would just do the trick, you know, plus 1, and you could figure out if it's exponential, quadratic, linear, things like that. But you can't use the trick on this one. Can't use the trick. And if you notice, this doesn't go up by +1. Okay, this goes up by +1, but this is up by +2. So that doesn't work. So because x is not +1. Okay, so here is the other way to figure out. You want to put the numbers into L1, L2, and we know to do that, you press stat and the number 1, which is edit. We've done this a million times. And what we're going to check is we're going to check the correlation coefficient. Correlation coefficient. Remember, that's the R, and see which one is the largest. Okay, we're going to see which one is the largest. You can also graph it too, but I'll go through it in a second. So let's show you this. So stat 1. Okay, so we have -2, -1, 1, and 2. And then we have -7, -7, -1, and 5. So now we're going to go to get the R, right? To get the R, it's going to be stat, move over to calc, and then are you going to do either number 4, linear regression, or we're going to do let's do one at a time. So stat, calc, it's going to be 4 or 5. That's quad regression. Or we're going to try, the only other one we really do is exponential regression, 0. 0, exponential regression. Okay, so we're going to try all of those. So first, let's try linear, and let's look at the R. Okay, so the R for this one is, pretty high, 0.95346, and that's going to be for linear. Okay, so now let's go to quadratic. So stat calc, the number's already in there, so just go right to number 5, quadratic. And you're not really supposed to use this. I'm not supposed to teach you to use this, but it's kind of sort of the same exact thing, and I feel like high school teachers, they use it anyway. So even though it's R squared, we're not supposed to use called like least squares, line, something like that. We're just going to use it anyway. Okay, but anyway, look at 0. Look at it and see how it's 1. Okay, R squared is 1. That is a perfect fit. Like, it can't get any better than that. So we already know the quadratic is the winner. And one thing I want to show you, exponential reg actually doesn't work. It says domain error, and that's because, you know, usually the y values are not negative because it doesn't go, you know, down into that third quadrant. So that's why basically it's going to be domain error. All right, so the winner is the quadratic. So we're going to go back to stat calc. We're going to go back to quadratic, and we're just going to get the equation. Okay, I have A is 1, B is 3, C is -5. So I have y equals 1x squared plus 3x minus 5, and that is the answer. That is the equation. If you really quickly put this into, let's see, x squared plus 3x, and then we have a minus 5, and I go to the table, you're going to see that these numbers match up. Okay, so -2 is -7, -1 is -7, 1 is -1, and 2 is 5, and that's the perfect table. So that's exactly what it is. All right, and then the only other thing you could do, it doesn't really work for this one too well, but if you go to that y equals, or second y equals, and turn your stat plot on, and then zoom 9, and actually have the line in there already, it kind of, I guess you could think it's exponential, but again, usually it's not below it. So this would be the curve. So that would be your quadratic. So sometimes it's really easy to tell, and sometimes it's not. Okay, so can also graph And to do that, it's turn on stat plot. Turn on stat plot. And press zoom stat. That was number 9. Zoom stat. And then we just wrote, what else? I'll write, can't be exponential because of negative y values. But this is, you don't really have to ever worry about. I need to switch my pencil too. Don't really have to worry about exponential ones. All right, number 9. So anyway, so easiest thing, put it into L1 and L2. Go to your lin reg, quad reg, and just look and see which one the correlation coefficient is closest to 1. And the quadratic was close to 1. It was 1. It was perfect. That means that is your answer. All right, moving right along. Average rate of change of that equation from -1 to 4. All right, so this is our x1. This is our x2. Formula for average rate of change. F of x2 minus f of x1 over x2 minus x. Remember, it's essentially slope, but we just use, instead of y2, we use f of x2. So it's going to be f of 4 minus f of -1 over 4 minus -1. F of 4. Okay, so I need some sort of work, so I'm going to copy the table because otherwise I have no clue what any of these answers are. And I'm going to go from -1 to 4. So y equals, I'm turning off that stat plot. Remember, that's the shortcut way to do it. X squared plus 4x, lots of parabolas today, plus 1. Go to my graph. Okay, so -1 is -2, 0 is 1, 1 is 6, 2 is 13, 3 is 22, and 4 is 33. All right, so I have my numbers, -1 and 4. So f of 4 is 33. So when x is 4, the y value is 33, minus -2, right? When x is -1, the y value is -2. 4 minus -1, and that's going to give us, minus and negative is really plus, so 35 over 5, and a final answer of 7. Now, the only thing I want to say is if it says algebraically, okay, if this was to say algebraically, table, no good, okay? You must plug into the equation. Okay, so what I mean by that, so this would be x is -1, and this would be x is 4. So you write the equation, y equals x squared plus 4x plus 1. I'll try to do this as quick as I can. So y equals -1 squared plus 4 times -1 plus 1. That's 1 plus 4 times -1 plus 1, which is 1 minus 4 plus 1, which is that -2. So this is just the other way to get that answer, or that y value of -2. And then for this side, it's 4. So same equation, y equals x squared plus 4x plus 1. Everywhere you see an x, you put a 4. So exponents first, if we follow PEMDAS, that's 16. Multiplying, that's another 16. 16 plus 16 plus 1 is 33, which is the same answer as over here. So, but if it says algebraically, table is no good because they consider that graphically. All right, 2 pages done. Number 10, we don't really do a lot of this in class at all. This is like more like of a 7th grade topic, but for some reason it shows up on the Regents a lot. I don't know. All right, number 10, a rectangular poster, so this is our poster, is designed so that the text is arranged in a square with a top, left, and right margin of 1 inch and a bottom margin of 3 inches. Okay, so basically you have your rectangle and then you have your square. Jeremy determined the area of the margins, which equation could be used to find the area of the margin. So basically you want to find all like this gray area in here. So I'm going to write that gray area. All right, so this might look familiar from 7th grade. So it's something called shaded area, and that's always the area of the larger minus the area of the smaller. Area of the larger minus area of the smaller. Okay, so shaded area, area of the larger, you have a rectangle. So it's going to be rectangle minus square. The rectangle is length times width, and your square is side squared. All right, rectangle. So, oh, this is really tough. Okay, so you want this dimension and you want this dimension. So to get this dimension, okay, watch. So from here to here is the length of the square. That means from here to here is the same length, okay? And since this is a square, each side, this is going to be x, this is going to be x, and this is going to be x. So this is going to be your x. Now from here to here, that's the same dimension as this right here. So that's 1 inch. From here to here is the same dimension as that. Okay, so this and this is the same length, and this is the same length. So that's also 1. So all together, 1 plus x plus 1 is 1 plus 1 is 2, plus x is x plus 2. Okay, so now this side. You know this right here is the same as this right here. Okay, that's going to be your square. So that's going to be x. Okay, and now get another color. From here to here, okay, and then we have, oh, actually, this should be from here to here, and this is actually should stay pink if I want to be consistent. So from here to here is this amount, and that's our 1, and then from here to here is this amount, right? That's going to be 3. Okay, so this is here for 1, and here to here is 3. So this is 1, this is x, and then this is 3. So all together, 1 plus x plus 3, 1 plus 3 is 4, plus x is x plus 4. All right, so we have length times width. So x plus 2 times x plus 4 minus the length of one side of the square is x squared. So now we just simplify. We're going to double distributes. So x squared plus 4x plus 2x plus 8 minus x squared. Combine like terms, x squared and x squared cancel each other out. 4 plus 2 is 6, so 6x plus 8, 4x plus 2x. All right, so not too bad. Hopefully that one was okay. Find the equation of the line going through. So an equation of those 2 points. Then we're going to write something's parallel, perpendicular, and then point slope. Wow, this is a lot. Okay, so we have our 2 points, 5, 10, and 7, 16. So x1, y1. And then we have x2 and y2. x2 and y2. So to get the equation, we always need a slope and a y-intercept. So we'll start with our slope. So m equals y2 minus y1 over x2 minus, which again, essentially is the average rate of change that we just did, but just in slope form. 16 minus 10 over 7 minus 5 is 6 over 2 or 3. So we have our slope. Now we need the y-intercept. So what you're going to do is you're going to plug into y equals mx plus b. You're going to use your slope, and you're going to use one of the coordinates. I usually tend to use the first one. And we're going to plug in. So y is 10, slope is 3, x is 5. So that's 15 plus b, subtract, negative 5 equals b. All right, so now that you have all the pieces to the puzzle, now you just put them together, and you make your equation. So the slope goes with x, and then the y-intercept is just the constant. So b is negative 5. All right, so it wants to know parallel. So parallel means same slope, so I have to use 3, and different y-intercept. So use any other number. So y equals 3x, I don't know, plus 2. Sounds good. Okay, then perpendicular. This is the one that's the negative reciprocal slope. Negative reciprocal slope, okay? And that means change the sign and flip the fraction. Change the sign, flip the fraction, and then it could be same or different y-intercept. It doesn't really matter. Okay, so 3 is going to go to 1 over 3. That's the reciprocal. And now we got to change the sign. So it's going to go to negative 1/3 x, and then any other number you want. Minus 4. I don't know. Sounds good. All right, and last thing for this one, point slope. To do point slope, this is the one that was a different formula. Y minus y1 equals mx minus x1. I don't know if you remember that, but they use this in the high school all the time. They're really wanting us to push this on you guys. So slope of 3, and then use either one of the points. We'll just be consistent and use the first one. So it's going to be x1 and y1. So y minus, your y1 is 10. Your slope is here for 3. x1 is 5. So it could be this answer, or you can go one step further and distribute, which is what I showed you in class. So technically either one of those are the answer. So 3x minus 15. So hopefully that wasn't too bad. And again, you're going to have to know that for high school. All right, couple more. Given y equals ax squared minus 12x plus 16, what is the with the axis of symmetry? Oh, they give it to us this time. Find the value of a. So this is a little tricky. So we know from the beginning that axis of symmetry is x equals negative b over 2a. So we know we need the a, the b, and the c. So a is actually a, right? Coefficient of a squared of x squared plus bx plus c, right? The coefficient of x squared is a. For b, it's negative 12. So B is negative 12 and C is 16. Okay, so let's plug in. So X we know is 2. So actually we're so used to writing an X, and me too, but we can actually plug in a 2. So it's the negative of negative 12 over 2 times what was A? A was A. So let's simplify. Negative of negative 12 is 12 over 2A. And at this point, I think the easiest thing to do is just cross multiply. So we have 4A equals 12 divided by 4, and A equals 3. So that was definitely on the trickier side. We haven't really done one like this before. So now your new equation, by the way, 3x squared minus 12x plus 16, you can actually check in the calc now. Check in calc. So if we were put this in here, so y equals 3x squared minus 12x plus 16, and we go to the table, we should have the 3 as our, yeah, I think that's right. Because that matches that. Yep. So if you look, your middle, 2 comma 4, right? I think I said 3, I meant 2. X equals 2 should be your axis of symmetry, and that number in the middle. So 0, I'll just copy this. 0, 16, 1, 7, 2, 4, 3, 7, 4, 16. And there you go. That axis of symmetry, X equals 2. We did it right. Go us. All right, 13, a bank advertised a rate of 5% interest compounded annual. Remember, that means every single year you compound annually, you just get more money. If a 10-year-old CD, so that's your N, is now worth, oh, be careful. This is why I chose this one. Now worth. So we're so used to the amount being the P, it's not, it's the A. So be careful. You want to find its original, and original is the P. So this is a tough one. Remember, money is always nearest hundredth. Okay. So we have A equals P, 1 plus R to the M. So the after is this price, 3257.79 equals P. 1, again, it's plus. Compounded annual means every year you get your interest. The R is 5%. And that is 10. So be careful. It is in the A. And I promise we did this one in class together. So 3257.79. Let's change this to a decimal, 0.05. Then let's add that together. That's 1.05, which makes sense, right? This number right here, this rate, the rate plus the 1, so the new base is going to be over 1, and that's how you know it's compounded annually, or that's how you know it's increasing, let's say, because it's a plus. And then to solve for the P, you're just going to divide both sides by 1.05 to the 10. So, no clue. 3257.79 divided by 1.05 to the 10th gets me this 2,000,458, and we want nearest hundredth. So the 0 does not round that up, so it's going to be approximately 2,000. So it started out at around $2,000 after 10 years with getting all the interest. Now it's almost 3,200 or 3,300. So that's pretty good. All right, last page, last 2 questions. Hopefully you guys are doing okay with this. The following two-way frequency table shows, that should be table, shows the results of a survey of the freshman class conducted to determine which gender owns, owns iPads versus Androids. Okay, so what is the relative frequency? That just means make a fraction of boys who prefer an Android, to all the students surveyed. Okay, so if you notice, you have of and to. Usually the of tells you what the denominator is, but if you have both of and to, we're going to defer to the to. So this is actually our denominator, and this right here is going to be the numerator. So of usually tells you which is the denominator, but if there is also 2, you look to the 2. So the 2 is going to be the answer. All right, so actually, this is not even filled in. We got to hurry up and fill this in. Oh boy. All right, so no, okay, I could do this, because remember, this plus 48 is 60. So 60 minus 48 is going to get, I could do that in my head. That is 12, okay? Nothing this way. Now this way. Those two numbers together, so that's 77. I could do these two now. Those two together gives me 157. And this is our, what we need for this right here. All students surveyed. All right, now we go this way. So this is your total. So something plus 48 equals 80. So 80 minus 48 is 32. And then this plus this gives me this. 65 and 32 is 97. All right, so now that we have all of our numbers, now we can actually do it. Boys and Android. Okay. So this is boys and Android. All right, so we have 48 over 157. That is our answer. And this is called joint relative frequency because you use numbers in the middle here. All right, last one. Write the quadratic equation in vertex form by completing the square, then write the turning point. All right, so this is the one where you got f of x. You guys can totally do this. Just remember this must be ax squared, where a equals 1, so it can't be 2x squared, 3x squared, anything like that. It must have the linear term, so must have a b term. That's important. And then to do complete the square, it has to be equal to c. All right, so remember you want to keep this. Don't change it to 0 and like that. Keep it as f of x. Let's move over the constant. So subtract 11 on both sides, and I'm going to swap the two sides. So x squared plus 6x equals f of x minus, again, minus 11. Keep that f of x. Complete the square. X squared plus 6x. Remember, this over here, we're going to write b over 2 squared. And b, we know, is 6. So it's going to be 6 over 2 squared equals f of x minus 11 plus 6 over 2 squared. So x squared plus 6x, let's see, 6 divided by 2 is 3, 3 squared is 9. Let's combine those, and we'll do our shortcut here. So the shortcut is drop down the sign, and this number right here is half of b. So b is 6, 6 divided by 2 is 3. And we have f of x, combine those, you get minus 2. So now I want to get this by itself, so I can get it back to vertex form. So add 2, and you'll have to know this for the high school too, by the way. They do this, I think, in geometry. X plus 3 squared plus 2. Obviously, you can't combine those. And then our vertex is negative 3 and positive 2. So this one is you do the opposite, and this one you do the same. And if you had to tell me the transformation for this one, it would be translated 3 units left and 2 units up from 0, 0, your parent function. So all right, that was a little bit longer than normal. We just went through a ton. Hopefully you guys are okay with those. If not, please reach out to me. I'll help you in any way that I can. Again, please make sure you post it on Google Classroom so you get the credit for all the work. And yeah, that's about it. So have a great day. Take care.